Good morning, students. Today I am going to take a concept of touching circle. Touching circle. If two circles touch each other internally or externally, but how touching in a single point? Okay, that is a very important concept. Now, if two circles touch each other internally or externally, the point of contact and the center of the circle are collinear. Now, see in the first figure, this is a circle 1 and this is a circle 2. The center of circle first is A and center of circle another circle is B, and it is touching externally. Why externally? See here, it is all the circles, they are both the circles, they are touching in a single point at point P, and this type of a touching circle called as a touching externally. Okay, and now see in the second diagram, this is a one circle, this is a another circle. This circle A is the center of first circle and B is the center of another circle. These circles are touching internally. See, one circle in between another circle, and therefore this point of contact is P, and according to the concept, this center of both the circle and point of contact, they are collinear, means APB and ABP, means all these 3 points are collinear. Okay, so this is the two concept, externally touching and internally touching. Now see the theorem of touching circle. There is only one theorem, and on this basis only you have to solve the practice set. Now see the students, what is the statement of theorem? Okay, here also see the diagram. Two circles are there, they are touching externally and they are touching internally. Okay, now see, if two circles touch each other, their point of contact lies on their line joining their center. Their point of contact lies on line joining the center, and here it is a point C. Okay, so according to that we have to prove. Very simple very simple question. Now see this diagram. In the given diagram, C is the point of contact. Both the externally and internally touching circle, their point of contact is C. And A and B are the center of two circles. Okay, this is the center of small circle and A is the center of big circle. Here too you can recognize easily. Now we have to prove that C is lies on the line AB, means on a segment AB, we can say. So C is a point which is on a AB, means ABC are the collinear, means in which first diagram it is a ACB and in the second diagram ABC. How to prove? Very simple. Let line L be the common tangent. If you are drawing the tangent from the for the circle which is a common between both the circle and which is passing through the point C, is it? L be the common tangent. Here also we have to draw the tangent. If point is on a circle, then we can construct only one tangent. By using the concept, you can draw the tangent L. L is a line which is tangent to the circle which is passing through point C. What is important? Whatever the point of contact of external and internal touching circle, from that point that line is passing and it is a tangent to the circle. So two touching circles, so line L is perpendicular to the segment AC, as well as line L is perpendicular to BC also. L is perpendicular to AC because AC is the radius of a circle. A is the center, C is a point on a circle, B is the center, C is a point on a circle. So AC is the radius of this circle and BC is the radius of this circle, and L is a line which is passing through C which is a tangent to the circle. So according to the tangent theorem, your AC is perpendicular to L as well as BC is also perpendicular to the L. Similar way, what you can say that AC is perpendicular to the line L. This AC is perpendicular to the line L and BC is perpendicular to the line L. Therefore, point CAB. Now, if they are perpendicular and on the same line, it means that The points are collinear. Finish. Just you have to use the tangent theorem and these two statements it will prove. Very simple. Now see how to solve the question which are based on this theorem and the concept of external and internal touching. Listen student, if external touching is there, it means that this point of contact is between the two center, and if it is external touching, then it is a at the last point of contact is at the last. If A is and B, now see if APB, that is a one-to-one correspondence. So AP plus PB is equal to AB. Means if it is asked to find out the distance between the center of two circle, it will come AP plus BP. And here what will come? AP minus of BP. You will get the distance between the center of two circle. Okay. So always remember, in a question externally or internally asked, according to that you have to draw the diagram and you have to solve the question. Now two circle having a radii 3.5 and 4.8 touch internally. Now see, this is a one circle, bigger circle having a radii 4.8, means it means that your PR is a 4.8 and another radii 3.5, means your QR is a 3.5, and they are touching internally. So find the distance between their center. Very simple, just I told you. What is the bigger area radii? PR. So PR minus of QR. Okay, PQ and QR is same because they both are the radii of this small circle. So you will get 4.8 minus of 3.5. So 1.3 is the distance between the two center of a circle when they are touching internally. How to write the answer? Let two circle having a center P and Q touch internally at a point R. Is it? QR is equal to 3.5 and PR is equal to 4.8. Now two circles touch each other internally by the theorem of touching circle. What you can write? Theorem of touching circle internally, PQR. They are collinear, and therefore PQ is equal to PR minus QR, and therefore 4.8 minus 3.5 is equal to 1.3. The distance between the center of two circles internally is equal to the difference of their radii. Always remember. And distance never be in a negative. Therefore, from the bigger radii, we have to subtract the smaller radii. So, you will get the distance between the two circles when they are touching internally. Always remember. This is very important statement. Next. Now two circle of radii 5.5 cm and 4.2 cm touch each other externally. When they are touching internally, at that time we have to subtract you have to find out the difference between their radii. But when they are touching externally, then we have to how to find out the distance between them? By just adding it. So let the two circle having a center P and Q, a radii of a circle is 5.5 and another radii is 4.2. Now the two circles touch externally by the theorem of touching circle PQR. They are collinear, and therefore PR is equal to PQ plus QR. So PQ is equal to 5.5, QR is equal to 4.2, and therefore 9.7. The PR is equal to 9.7 centimeter. So this statement no need to write in the answer. Okay student, just this is for the more information I wrote here. Means you have to remember these two concept. Means any example you can solve. The distance between the center of two circle touching externally is equal to the sum of their radii. Is equal to sum of their radii. Now next see. Question 3. If radii of a two circle are 4 cm and 2.8 cm, draw the figure. These circles touch each other externally and internally. Now see. Firstly, you have to take one 4 cm distance. Draw and circle. Draw and circle. 1 minute, wait. Okay, now at point Q, okay, you have to draw the PR 4 and 2.8, so it will come 6.8. At P you have to draw a circle at 4 centimeter. Now from R you have to draw a circle of 2.8 centimeter. Here what to do? Draw the bigger circle. Now at point 2.8, from this Q point to 2.8 you have to mark at the point R, that is the center of another circle, and from R you have to draw the circle. Okay, now see the question number 4. In the adjoining figure, the circle with the center P and Q touch each other at R. A line passing through R meet the circle at point A and B respectively. Prove that segment AP is parallel to QB. Triangle APR is similar to triangle BQR, and angle RQB if angle PAR is already given. PAR is 35 degree. Now listen students, very simple. See the diagram. This is a center of two circle P and Q. Okay, so what is the touching? They are touching externally at point R. You have to draw a line which is passing through R, and those the point A and B are on a circle like this. After constructing the diagram, now see, we have to find out these three things. We have to prove it. First, the circle of a center P and Q touch each other at point R. Okay, at point, here it is R. By the theorem of touching circle P, R, Q, they are collinear. So in triangle PAR, segment PA is equal to PR. Is it? Why? Because of red I have same circle. Therefore, angle PRA and angle PAR both are same because isosceles triangle. Okay. Similarly, this triangle also, consider the triangle BQR. In that also QB is equal to RQ. If QB is equal to RQ, it means that in this circle, this triangle QB are also isosceles triangle. If this is isosceles triangle, then your angle is QRB is equal to QBR. Okay, this is the second statement. Now from first and second, what you can say? All of you know that angle ARP is equal to QRB. Or why? Because of opposite angle, vertically opposite angle. So ARP is equal to QRB, vertical opposite angle. Now see, these two angles are equal. These two angles are equal. It means that angle PAR is equal to angle RBQ. So these two angles also equal to each other. Now 1, 2, 3 and these 4. These 4 angles are equal to each other. But what happened? These two are alternate interior angle. When AP, and by the converse of alternate interior angle, what we can say that AP is parallel to QB. Therefore, hence proved AP is parallel to QB. Now listen, if these two angles and these two angles are equal from these two triangle, means by A test they are similar. Our second is also proved. Now RQB, RQB, this is the 35. So what is PAR? Very simple. RQB is 35 degree. I told you this was the by A test. RQB plus RBQ plus QRB, all it is equal to 180. 1 to the sum of the angle of a triangles, and by that, and two angles are of equal measure because they are isosceles, and therefore angle RQB plus 2 times of 35 is equal to 180, and therefore RQB is 180 minus of 70, that is 110. Very simple. Because two angles are equal because of isosceles triangle, and therefore by using the sum of the angle property of triangle you can easily find out the remaining one angle. Okay students, so up to this you have to write in your notebook and try to solve the question number 5. Okay, or instead of that try to solve the 2 questions which are given in your textbook activity. Solve the activity and send me related to 3.2 whatever activities are given related to touching circle, that you have to complete in your notebook and send me up to session. That is your today's homework is activity. Okay students.